Hey everyone, welcome back to the channel. This is Ahili Bhattacharya, and today we are diving into one of the most powerful concepts in statistics, variance and standard deviation. This is the last property, right? So we start with the property number 3. This isn't just a property, it's a super useful alternative way to calculate variance. The variance of a variable x, often written as var x, is defined as the average of the square differences from the mean. If you have n data points, its variable variance x is equal to 1 by n summation of xi minus x bar whole square, and we derive it. See, where xi is each individual data point, x bar is the mean of all data points. But calculating all those differences can be messy, right? So let's see how we can algebraically do it into a more calculation friendly form. Watch this magic trick. We start with the definition here and let's expand that square. Just like algebra in class, we used to do, right? A minus b whole square is equal to a square plus b square minus 2ab. So we get this. Now see, if we split this term into three different terms, the summation sign is distributive, so we do this, we get this. All right, let's look at each part. Summation xi square is just the sum of all squares of our data points. Summation of x bar square, since x bar is a constant, the mean is one number for the whole data set. Adding it up n times is the same as nx square. All right, 2x bar xi, here 2x is a constant, so we can factor it out, 2x bar and summation xi. And what is summation xi? That is just nx by definition. So we get this. Now, plugging that all back in, we get this formula. Now see, this is we get by distributing the 1 by n. And we have it, the golden formula. This is so powerful. To find the variance, you don't need to calculate every single difference from the mean. You just need the average of the squares of the data points, 1 by n summation xi square, the square of the averages of the data points, not the summation, the x bar square. Okay? So, subtract the second from the first and boom, you have got the variance. Remember this, it's about to make our next problems way easier. Now, let's use this powerful formula to crack some problems. This is a classic problem, okay? This is like they give you a little and you find a lot problem. See, the standard deviation from 32 observation is 5. The sum of the observation is 80. What is the sum of squares of this observation? This is the question. Now you need to write the findings first. See, sigma is 5, sigma is the SD. Summation of xi is 80 as given. N is 32, the data points. You need to find summation xi square. See, as you have got the sigma, you can get sigma square, which is the variance 25. Therefore, we calculate the mean xi by n, which is 80 by 32 and 5 by 2. Then variance of x will be 1 by n summation of xi square minus x bar square is equal to 25. And you find it that summation of xi square is 1000. So yes, that's the answer. The sum of squares is 1000. See, like it's straightforward. It was very straightforward with our formula, right? No messy differences needed. Now, let's tackle a two-part question. First, a classic derivation. Find the mean and SD of first n natural numbers. Our data set is simple. 1, 2, and 3 and goes on till n. Find the mean first, okay? So, how do you get the mean? Mean is summation of xi by n, therefore is equal to 1 plus 2 plus goes on till plus n by n, which is n into n plus 1 by 2n. And we get the answer n plus 1 by 2. Pretty straightforward. Now for the standard deviation, we need the variance. Let's use our magic formula. We need summation xi square. Here, see, the summation xi square, 1 square plus 2 square plus goes on till plus n square. This has a pretty basic formula which you need to just memorize it. You need to know this formula to solve this question, which is summation of xi square for 1 square plus 2 square plus goes on till n square is a 1 by n by 6 into n plus 1 into 2n plus 1. Okay, like this you can find the variance x. See, here the SD will be the root over of variance, right? So the answer is n square minus 1 by 12 whole root over. Okay, now see the next part. The mean and SD of 20 points are 15 and 10. An additional point 5 which was left out is included. Find the correct mean and SD. This was the question. Now see, you first write the findings. N is 20, x bar is 15, sigma is 10. Therefore, sigma square will be 100. The new n1 will be 21 because the number 5 was additionally added and which was already left out, right? So now the data point will be 21. X bar of the old one is what? Summation of xi by n is 15 as it was given. Therefore, xi, the old one, is 300, but the new xi will be 300 plus 5, 305. Okay. And the new mean will be 14.5, like that. Now see, the incorrect variance is 1 by n summation xi square minus x bar square. You write the previous variance and you calculate it. The xi square is 6500. Therefore, the correct one will be 6500 plus 5 square, 6525. Okay. Now, the new variance will be, as you put the new terms, 1 by n was 21, xi summation of xi square is 6525, which is here, and the mean is 14.5. Therefore, you get the answer for 100.46. Therefore, the sigma, which is the SD, will be 10.02. Okay, so you get the answer like that. Now, the mean is approximately 14.52 and the new standard deviation is basically 10. Adding that one low value pulled the mean down a bit but didn't significantly change the spread of the data. We can understand from this question. Now, our final problem is like being a data detective. For a distribution of 280 observation, the mean is 54. Okay, and the SD is 3. Alright, on checking, it was discovered that an observation which should correctly read as 66 and 88 had been wrongly recorded as 64 and 80 respectively. Calculate the correct values of mean and SD. This is more or less like the previous question. You need to write the findings first. N is 280, x bar, which is the mean, 54, sigma is 3, sigma square will be 9, and therefore we first you find the mean. The mean is no, so first you find the xi. You have the mean, all right, 54. Then you get the xi. Xi is 15120. Then the new summation xi will be what? 15120 minus 64 plus 80 minus 66 plus 88. So you get the answer 15130. This was wrongly recorded. You get right. 66 and 88 was wrongly recorded, so it is subtracted. And no, 64 and 80 is wrongly recorded, so this is subtracted. See, and 66 and 88 should be the correct value. Okay, see, sorry, I have pointed it out wrong. Yes, 64 and 80 was wrongly recorded, so it is subtracted here. Now you see, you find the means 15130, this is a new value, and 280 554.03. Then you find the variance, and then you get the summation xi square like this, 819,819,000, and therefore the new summation xi square will be this. You take the squares and do the summation 820604, and therefore you get the sigma, which is 3.38. Okay, so like our detective work is done. The correct mean is 54.03 and the correct standard deviation is approximately 3.38. The errors had a small but noticeable effect. All right. So, yeah, that's a wrap up. We derived a crucial formula for variance and then we became masters of finding missing statistics and correcting errors in a dataset. The key takeaway is that variance is equal to mean of squares minus square of the mean. This is your secret weapon for so many problems. Now that we are absolutely pros and absolutely pro at this absolute measures of dispersion like variance and standard deviation, a natural question pops up. What happens when I want to compare that spread of two completely different data sets? For example, is the variation in salary greater than the variation in employee age? How do we calculate it? That's where relative measures of dispersion come in, and that is exactly what we will be diving into in the next video. We will explore concepts like the coefficient of variation, which is a game changer for making these kind of comparisons. So, if you're excited to become a data comparison ninja, make sure you don't miss it. Hit that subscribe button and ring that notification bell. In the meantime, if this video helped you, give it a thumbs up and share with a friend. Thanks for watching, and I'll see you in the next one. Bye. Take care.